Hello, today I'm going to be servicing my Yamaha DSP-A1 integrated amplifier that I've owned for about 16 years. This was Yamaha's flagship processor in the late 1990s, and I would like to rescue it from an early grave. It has three major problems. First, the display has not only the well-known flickering problem, but the second line of information is almost always blank, and if it does work, it frequently has garbled messages. Second, the user settings are lost within 15 minutes or so after losing power. And third, the main left and right channels almost never function. With the help of the service manual, I'll walk you through disassembly, debugging, and repairing each problem. Here's a diagram of the initial disassembly procedure. As you'll see, I did not follow this exactly because I removed the front panel without removing the bottom panel. This does not work that well, and you should just remove the bottom panel first. Here, I'm removing the front three screws of the bottom panel in order to free the front cover. It would have been better just to remove the bottom panel completely. I wrapped electrical tape around the front volume knob in order to get a better grip. With a firm pull, it just popped right off. There was never any need to remove the input selector knob. Here's a diagram of the general layout of the printed circuit boards. There are 27 boards inside, but this diagram shows just some of the important ones. The boards are grouped into categories such as video, main, and DSP, with this number indicating which board in the category. In this video, we're going to be servicing the DSP-3 board to fix the display and the function board to fix the user settings and the audio problem. I'll talk later about how I determined it was these boards that needed servicing. If a particular circuit board is not shown in the previous diagram, then the exploded view diagram can help since it does show every circuit board. Again, the boards that I'm going after are the DSP-3 board and the function board. Further disassembly is required to gain access to these boards. You have to remove both the side panel because it is hooked onto the front panel, and then the front panel itself. I didn't follow this exactly, but you'll see what I did. Be aware that the screw I am removing now is not listed in the service manual. Also, since I didn't remove the side panel first, I had to remove these two screws as well. Once I did that, this piece comes out and the front panel is almost free. At this point, I decided to remove the bottom panel entirely. Finally, there are two screws underneath the front controls cover that need to be removed. One last thing, do yourself a favor and remove this screw. It fastens directly to the DSP-3 board behind it. Now we're ready to start unplugging cables. There are two types of cables, white ribbon cables and green wire connectors. I didn't have any problems plugging and unplugging these things, so they seem quite reliable. First, there are 3 wire ties that have to be cut. Next, there are 3 ribbon cables that need to be unplugged, followed by these 2 wire connectors. With all of that, I could finally lift up the front panel and get to the circuit boards behind it. Here's a look at the DSP-3 board. The next step is to remove these black plastic stoppers, one on each side, followed by unplugging this cable. I didn't find an easy way to unplug this cable, so I just left it. Lastly, I carefully pulled back each of these plastic holders, and the board just popped out. I then repositioned the whole unit so I could take a closer look and repair the board. The problem is these cracked solder joints, which you can clearly see as I zoom in. It's those circular cracks around each pin. The first thing to do is resolder both rows of pins that connect directly to the display. There are a total of 138 pins, but it goes quickly once you get the hang of it. I'll work along this row, and then come around and work on this row. I put the DSP-3 board back in, reassembled the unit as much as necessary, and turned it on. Good news and bad news. The good news is that the top row of the display does not flicker anymore. The bad news is the bottom row is still blank. I can play around with the input selector, and that works fine. The DSP-A1 has a built-in diagnostic function. It's activated by holding in these 2 buttons while turning on the unit. I can then select the display check. When that's started, it will turn off the display, then turn on all pixels at full intensity, half intensity, and then into a lattice pattern. That all seems fine, except that the bottom row is still blank. The fix for that problem comes later in this video. Not knowing what else to do at this point, I decided to plow on and work on the user settings problem. I read on the internet that the user settings problem is caused by a failure of a 47,000 microfarad 5.5 volt supercapacitor that holds charge on the processor. I could find only one of those in the parts list. It's capacitor C21 on the function board. If you take a look at the schematic, you can find C21 sitting right at the supply pin of the processor. Continuing with the disassembly at this point, I was glad to see that the function board was quite loose. The way to completely remove the function board is to first remove the side panel, which then allowed me to disconnect these 2 ribbon cables, followed by these 4 wire connectors, followed by these 2 screws and bracket, followed by this ribbon cable. Now, do not remove this cable at this connector, because unless you have the hands of a 3-year-old, it is very difficult to get back in. Just remove the function board first and then unplug the ribbon cable from it. Here's a first look at C21. There is some residue on the terminal, so this cap definitely looks bad. However, what is more interesting is what is this? That silver residue actually rubs off. Here's another shot at it, and you can see there is some obvious damage to IC5. I'm not sure if that's from the electrolyte leaking from C21 or for some other reason. This is significant because I suspected that IC5 might be the source of my audio problem. I'll talk more about that later. For now, I'm going to replace the capacitor with a new one that I picked up from DigiKey. The back of the capacitor was crusted over with this brown residue. I don't have any visuals of testing the replacement capacitor, but I can honestly say that it solved the problem. I had the unit unplugged for several days and it retained the user settings properly. The final step is to talk about the audio problem and the importance of IC5. I had 3 important clues about the left and right audio problem. First, it always happened to both channels at the same time. I would either lose audio altogether or it would be highly attenuated. Second, I knew it was not the amplifiers because I could feed in a signal directly via the main input connectors in the back of the unit, and the amplifiers always worked. Third, the mute didn't work on the left and right channel either, while it did work on the other channels. It turned out that IC5 was the common link between these problems. Let's take a look at this part of the schematic. IC5 is an LC78213 analog function switch. The audio signals come into this part of the circuitry and pass through IC5 right here. IC5 also controls the mute signal. If the mute is on, then there is a bias on the base of these transistors which adds a load to the audio signals, thus reducing the volume. Therefore, IC5 seemed like a good candidate as to the source of the problem. The next question, though, is whether that could be responsible for other strange problems, like the missing line on the display. To answer that question, we have to look at this part of the schematic. This shows the control signals of IC5. There are 3 serial control signals: a clock, a chip enable, and a data input. When the chip enable is active, IC5 looks at the data input for a predefined set of address bits. If it sees the right address, then it looks at the data again and receives instructions on how to open or close any of its switches. These control signals are part of a serial bus that uses 2 chip enables. Here are the clock and data signals which run to every chip on the bus. Here's the first chip enable, but more importantly, here's the second chip enable. It enables IC5, but it also runs off and goes to the display board, where it enables the display driver chip that controls the second line of the display. I figured if IC5 is damaged, then it might be interfering with the operation of any chip activated by the second chip enable. Considering that I saw visible damage to IC5, I decided just to cut IC5 off the circuit board to see if the serial bus, and thus the second line of the display, would work again. If it did, then I could replace the chip and see if it brings back my front audio. With IC5 cut off the circuit board, it's time to test again. Sure enough, as you can see, the bottom line of the display is working again. It doesn't flicker, and it is presenting the right information. If I activate the display check, I can see that all pixels in the display come on. They start with all off, then all on, half intensity, then the lattice pattern. With that looking good, it's time to put in the new chip. It took a fair bit of effort to desolder the vias on the circuit board. I used a combination of my plunger and solder braid. The braid worked well when I pushed the end of it into the via with my soldering iron. Anyway, after a while I got them cleaned up enough that I could install a socket. I installed a socket because if I got a bad LC78213, it's easy to replace. Worst come to worst, I could hardwire the appropriate connections just to get the unit to work again. It's straightforward to solder in the socket. I picked up two LC78213 chips off of eBay for about $5 a piece. You usually have to bend in the terminals a little bit, and then it will plug in very easily. The final test is at hand. Alright, so the chip is in. I've put it back together a little bit, and we're ready to test. So we're going to turn it on. Comes up. Bottom line still comes up in the display. And I've got pure stereo mode. So we're going to turn the volume up a little bit. And sure enough, I got left and right audio coming out. I can switch to Pro Logic mode. Center channel is still working. Left and right channel is still working. Go back to stereo. I think it's good. I think it is time to put it all back together and see how it works for the next several months, but I think we're good. I have to say that I think Yamaha built a very serviceable unit. It's virtually all metal construction that is easy to take apart. The service manual is very complete, and for about $12 I saved it from the electronics graveyard. If you have one of these or something similar from that time period from Yamaha, you might be able to service it. I hope you picked up a few tidbits from this video. Thanks for watching. So long!